Hello, and welcome to the 9th in a series of films about the standard level organic topic. Up to this point, all the molecules that we've looked at really have been hydrocarbons, that is to say they've been made of carbon and hydrogen. Now we're going to start looking at the alcohols, and these are going to be the first molecules that we look at that have another element in, and in particular this is going to be oxygen. And so these molecules are molecules that contain an OH group, so hopefully by the end of this film you'll be able to identify an alcohol when you see it, and you'll be able to name alcohols that are up to 6 carbons in length and have straight chains, and also you'll be able to classify alcohols into 3 different categories: primary, secondary and tertiary. Okay, so first of all let's start off by looking at what an alcohol is. Okay, as I say, this is the first kind of molecule that we've looked at in the organic topic that has more than just carbon and hydrogen, and here we can see on this diagram that we've got an OH group, so the O is the red atom. Okay, and here's a displayed formula of an alcohol, and once again you can see that it's got the OH group in it. And if you're going to write a molecular formula, or this is a structural formula in fact because it's telling us about the structure of the alcohol, then we can recognize an alcohol because it's got OH in its name. Now this all might seem very simple, and hopefully it does, but as we'll see later, the order that you write these 2 letters in is quite important in this structural formula. So anything with OH in, we're going to call an alcohol. Okay, now once we've decided that a molecule is an alcohol, then we can start going about naming it. Okay, because all alcohols end in ol. Right, now we use exactly the same kind of prefixes as before to denote how many carbons there are in the chain. So if we start off by looking at methanol, then as usual carbon forms 4 bonds. Okay, so we're going to have this CH3, but we've got to have an OH group in it, so there's the structure of methanol. Okay, if I was to draw the structure of ethanol, well, that would just have 2 carbons in it and then the OH group, and I'm going to be very, very bad here and not draw the hydrogens just because I want to save a bit of time. Okay, propanol has 3, and so on and so on and so on, up until hexanol. We don't have to go past 6 in the standard level topic. Okay, so that's how we name them, but it is important to realize that just like before with the alkanes and alkenes, 2 alcohols could have the same molecular formula but have different structural formulae, and in that case they'll be structural isomers. Okay, so here are 3 different molecules, all alcohols, and all having the same molecular formula, which would be C4H9OH. Okay, or you could say C4H10O. Okay, so they've all got this formula. What's different about them? Well, the difference is where the alcohol group is. So if I draw myself a 4-carbon chain, that's why these 2 are called butanol, because their longest chain is 4. Okay, and if I then put in all the bonds that the carbons can have, right? What we'll see, hopefully, just like before when we were talking about branches on a chain, we can hopefully see that there's 2 different places that I could put my alcohol group. I could put it on the end carbon, and notice that all these 3 positions here in green are the same as one another because they're all on the end carbon, and they'd be the same as putting it on this end carbon, right? Or I could put my alcohol group on one of the second carbons in the chain. Okay, so butan-1-ol would have, so I'm going to just highlight this one in green, okay, because that would have the alcohol group on the first carbon. That's what this 1 means. Okay, it means that the OH group is on the first carbon in the 4-carbon chain. Okay, here we've got butan-2-ol, so let me highlight that one in red because this corresponds to having the alcohol group in one of these 2 red positions. Okay, so this number here tells me about where the alcohol group is, and this part of the name tells me how long the longest chain in the alcohol is, just like before really with the alkanes. If we look at a slightly more complicated example, so that's here methyl 2-propanol or methyl propan-2-ol, What this means is that we've got propan-2-ol, so 3 carbons is prop. The alcohol group is on the second carbon. Okay, so we might have an OH group here, that's why it's called propan-2-ol. But in addition to this, we've got a methyl group attached to this carbon chain. Now if you think about where could this possibly be, because this doesn't have a number before it telling you where the methyl group is, and that's because it doesn't need to, because if you think about it, if I put the methyl group on one of the end carbons, so in any of these 6 positions here, what would I have done? Well, I'll have extended the chain. I'd have made it 4 carbons long, and now I'd have a 4 carbon chain with an alcohol on the second carbon, and I would be talking about butan-2-ol, not about methyl propan-2-ol. The only place I can put my methyl group, if it's going to be called methyl propan-2-ol, is there. Okay, so this would now be a CH3, and my molecule would have a longest chain of 3, whether I went along there or along the middle, doesn't really matter, and it would also have an alcohol on the second carbon, so methyl propan-2-ol. We could, if we wanted to, call it 2-methyl propan-2-ol, but this 2 is kind of redundant because there is only one place for that methyl group. And as you can see here, all these formulas are structural formulas, and we've put in brackets the OH group if it's not on the end of a chain, okay, to show that it's coming off this carbon, and then we carry along the chain further, we get to another CH3. This molecule here has 3 CH3 groups. If I just highlight them in blue here, there's one of them, there's another, so that's why this is CH3 3 times, and then a carbon and an OH group. Okay, the last thing to say about alcohols is to talk about the different kind of categories of alcohol that we have, and these are primary, secondary and tertiary. And what this relates to is how many carbons are directly attached to the alcohol carbon. So first of all, if we have a look at the primary alcohols, and let's just highlight in red the alcohol carbon. The alcohol carbon is the one that is attached to the OH group. Okay? Now methanol here, with its 1 carbon atom, has no carbons directly attached to the alcohol carbon. Butan-1-ol, because this is 4 carbons in the alcohol on the first carbon, has 1 carbon directly attached. I'll just highlight that one in green, okay? It has 1 carbon directly attached to the alcohol carbon. So if you have 1 or no carbons directly attached to the alcohol carbon, you're called primary. If you've got 2 carbons, so as is the case here in 1, 2, 3 carbons, propan, second carbon along has the OH group, propan-2-ol, or here in butan-2-ol, again let me highlight in red the alcohol carbon and then highlight the carbons that are directly attached to it, we can see that there are 2 carbons directly attached to the alcohol carbon. Okay, so this is called a secondary alcohol. And in a tertiary alcohol, like in methyl propan-2-ol that we just saw on the previous page, here's the alcohol carbon, and here are the 3 carbons directly attached to it. Or in this kind of more general notation, again, here's my alcohol carbon, and here are 3 R groups, which are just kind of carbon chains that we're not specifying. Okay, so 3 carbons directly attached to the alcohol carbon. We're calling this a tertiary one. Notice here that this R is called just R, this one's called R prime, and this one's called R double prime. This is just so that we're saying that they're different from one another. Okay, it's just a way of distinguishing one group from the other, but don't worry about that too much. Okay, the important thing is you know how to spot a primary, secondary and tertiary alcohol, because as you'll see later on, they react in very, very different ways. Okay, so the idea by the end of this film was to understand what an alcohol was and how we can write structural formulae for them and name them and so on, and also to know what we mean by primary, secondary and tertiary alcohols. If there's anything there that didn't make sense or anything you want to ask about, then please feel free to come and see me or to post a comment on the YouTube channel.